everyone! Unreal Engine 427 has arrived, so what can you expect? In-camera VFX goes next level with a slew of efficiency, quality, and ease of use improvements. Take advantage of path tracing for stunning final images, utilize out-of-the-box access to Oodle and Bink, production-ready pixel streaming, and much more. Check out the release notes for a complete list of new features and improvements, then head over to the Epic Games Launcher or GitHub to download 427. We've added 2 new courses on the Unreal Online Learning Portal this month, focused around building better experiences. Explore accessible design to help your users overcome unique challenges or disabilities, and dive into audio mixing and effects to craft compelling soundscapes. Start these new courses and others over at the Unreal Online Learning Portal. Ready for your projects to sound as good as they look? Unreal Engine 5's meta sounds represent a complete redesign of the engine's audio features. Watch and listen to our development demonstration on the Unreal Engine YouTube channel that walks newcomers through some of the cool features of meta sounds and how to go about implementing them into your own projects. Powered by Audi Business Innovation's automotive visualization platform, Lamborghini's new real-time car configurator leverages Unreal Engine photorealism to deliver best-in-class visuals and provides a complete automated digital pipeline to deliver the best customer experience possible. Drive over to the feed to see how they're making it even easier to find your dream car. An ancient Roman murder mystery isn't the only fascinating story behind the Forgotten City. We caught up with Modern Storyteller to learn how the game transitioned from Skyrim mod into a critically acclaimed standalone title. Read about the small team's journey on the Unreal Engine feed. Genre-building Viking adventure Tribes of Midgard's release was just last month, and to celebrate, we caught up with the Norsefeld team to discover what brought the new studio together and dig into how they created the bright and colorful comic book aesthetic. Venture over to the feed for the full interview. With the finish line just weeks away, real-time technology came to the rescue and enabled real-time to deliver 2.5 hours of additional cinematic cutscenes in record time on Codemasters' new F1 2021 game. Head to the feed to learn how they did it. And now over to this week's fantastic Karma earners, many thanks to Clockwork Ocean, Tsumi Saki, Every Nun, Kahale18, Crewdimer, Redog, Alex Andois, Devin Sherry, Bitrot, and Shadow River. In our first spotlight, 3 brave friends embark on a mission to find the elusive new idea. Produced by Funbox, this incredible short plays on how the creative process can be full of obstacles to overcome. Watch the full short on Funbox Creative Productions' YouTube channel. Check out Slime Heroes from Pancake Games, a game where the slimes finally get their shot at being the heroes. With help from your friends, explore a mysterious world full of magical plants and creatures, discover hidden passageways, and fight back against corrupted minions to save the world. Wishlist this slimy adventure on Steam. And lastly, we'll leave you with Weird Things, an animated short from a 2-person team about 2 weird beings that became friends, despite their differences. Watch the full short on Martina Stamova's ArtStation page. Thanks for watching this week's News and Community Spotlight. Hi, and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Amanda Shade, Community Manager here for Unreal Engine, and joining me this week, we have a couple of amazing technical artists from SideFX. So first off, welcome to My Owl. Want to say hello?
Hi, I'm Mai. I'm a technical artist at SideFX Labs team.
Nice. And we also have Simon Verstraete.
Hello, I'm Simon, and you might see me from tutorials. So I mainly make tutorials with SideFX, covering things like generating procedural approaches and bringing them into game engines.
Awesome. Well, first of all, thank you both for joining us. We're excited to dive in and kind of talk about SideFX Labs and what Project Titan sounds pretty interesting. And before we dive right in, I do want to give a shout out. We have Ben Mears, SideFX Community Manager, in the chat, and Paul, I'm not going to try and say your last name, sorry, and the SideFX Labs lead. So hopefully they can help answer some questions for you. And Mai, feel free to take it away.
Thank you, Amanda. So I would like to give a brief introduction to SideFX Labs for those of you who may have not heard of us yet. We are part of Houdini, and we offer open source and free tool sets. We have currently more than 200 and growing number of tools. Our turnaround is much faster than the main branch of Houdini, because Houdini releases about twice every year, but we release tools whenever we finish them. And we are pretty much community driven and production oriented. So we bear in mind what are the needs of people who build actual games and in real time environments. So we provide either quality of life tools or tools with advanced algorithms or anything that improves your workflow. So Labs is currently looked after by Paul, me, Simons, and many other contributors. We make generators, utility tools, and other third-party integration tools. If you go to SideFX products, SideFX Labs, you can find a lot of information there about Labs, like the overview of our tools, the installation guide, a bunch of industry stories, and other resources and links. Another useful link you may go to is /learn from SideFX. There you will find carefully curated learning paths and official tutorials, either about Labs tools or just general Houdini tools that you can benefit from. The official code base and resource home of Labs is on GitHub. This is more for the tech-oriented people in the studios. You can see our commit histories and daily releases from here. You can find download guides and deployment guides if you want to either download the Labs tools for yourself or deploy in your studio. As community contributors, you can also send us pull requests if you build something cool. We'll be happy to include that into our tool set because it's all open source. At the bottom is a link to our GitHub page. We also have an ArtStation that's more artist-facing. Over there, we showcase what our tools can do, and sometimes we'll post tutorials as well in the forms of either videos or slides. Every Friday, we'll try to do a Free Tools Friday thing. We'll do a weekly post of new or old tools just to introduce its functionalities and how to use them to the community. And again, at the bottom is the link to our ArtStation page. Welcome to visit. Just a brief intro to how to get Labs. So the easiest way is open Houdini and go to the SideFX Labs shelf tool usually at the top left, and you can find the updater over there, and that will give you the easiest way to update tools. You could also download it from GitHub, or if you are a tech artist or engineer, you could use command lines for studio-wide deployment. After this, I wanted to talk about our newest Vertex Animation toolset, which we spent quite some time developing it, made a big upgrade from the 2.1 version. So now we've moved to Vertex Animation 3.0. In this version, our main objective is to streamline the workflow, so make the whole process of exporting simulations from Houdini to Unreal more easy, but at the same time to give you more ability to achieve advanced effects or more complicated things, because we've seen a lot of studios and users developing their custom solutions. So we thought it might be a good idea just to build in those hooks or capabilities inside the tools, so you make it easier for you to extend what you want to achieve. So what I'm showing you right now is a bunch of examples. I used very high fidelity assets just to show how far we can push the quality ceiling. So in these examples, it's very extreme in terms of number of details and pieces, but Unreal Engine and our toolset can handle it pretty well. This is an example of fluid simulation, which is a thing that Vertex Animation can handle very well. And this is a soft body deformation. So metal deforming will be very easy using Vertex Animation. So this is a particle. It's an alternative to Niagara system. So there are pros and cons of both. In this case, you could use a lot of particles as well as instancing them all over the place. So next, I would like to just jump into a demo project that you can find in our stage page. So if I'll just show you where the location is. So if you go to our labs and go to the Vertex Animation Part 1, this is the basic introduction of our the tool set and the basic tutorial of everything. So under this slide, there's a link here, links to a real drive location, which you will find a Part 1 of our guide. A Part 2 is coming. But there's also a zip file which is containing the demo project in Unreal, which is the one I'm showing you right now. So there are 4 modes of that tools. The first one is used to be called Fluid. I'm expanding the name to dynamic remeshing because the basic idea is that you basically can remesh anything and play that as an animation in real time. So in this case, I just have generated numbers and they play continuously from frame to frame. At the back is more like traditional fluid animation, and that's showcasing we added the new motion blur effect. So let's do some dive into this one first. So one thing we added per popular request to the fluid mode is to have UVs. It used to be a bit difficult because fluid mode because because the topology of the mesh changes every frame, it might be difficult to do the UV. So the UVs are sent over by textures. So the textures read the UVs and apply to the mesh. Then you can have normal maps or other maps you can apply to the mesh. So we have, in general, this is across all different modes, we have 3 tiers of normals. So the most lowest quality tier is also the, let's see, is also the most memory efficient. In that mode, we just send the UV to the alpha channel of the position texture. So we compress a vector 3 normal into a float, so we can store it. Then we restore that in shader back to the vector 3. So in this one, you can see the lowest tier of normal, which is what we call the compressed normal. So to use compressed normal, you send the in Houdini here, you can turn on the export compressed normals in position alpha. Then in the material instance, you can check the compressed normals in position alpha and then turn on use compressed normals. The second tier, which is a bit higher quality, which uses our rotation map, is if you turn this off and don't turn on support surface normal map, this is the second tier of normals you would get. It has less artifact, but you can see it's still smooth because it can't support a normal map. To support surface normal map, we need to turn on this one. In this case, you can see the details. So this comes from a normal texture. So if you go to the parent material, you'll see that what you simply do is drag the UV map that comes from the texture, apply it here. Then this is just default grass normal map, and you supply it to the surface normal map here, and you get normal to your mesh. And this workflow is same for every other mode too. If you want to get a normal map, just plug it in here. The other thing I want to show you is the motion blur here. So to do motion blur, you first need to enable compute vertex velocity in the project settings. Then after that, for fluid motion blur, it's a little bit special. That's why I talked about it first, because the other 3 modes use a different approach. So for the fluid mode motion blur, you have to go to here, dynamic remeshing. You have to export the velocity in the color channel. So the velocity will be encoded in the color texture, and you can pick it up here in Unreal. If we look at the material of this. Here. So this here, the color RGBA will mask out the velocity and use our material function transform velocity to turn the velocity in Houdini into a velocity in Unreal, then plug in here to the local space point velocity this frame. So what this would do is that it will let the shader know what's the point velocity on each frame, and internally we'll use a function called previous frame switch. and this will allow us to compute the per vertex motion. That's how you do motion blur. Let's jump to the next mode, particles. Let me close these. So for particles, we have several new functionalities we added. One of the first things is interpolation. Particles, you cannot do interpolation in the previous version because the particle counts are changing from frame to frame. So we did some tricks in the generation of the textures to make sure that the consistent particles are stacked on top of each other in the texture so that you can do interpolation now. So like this one, you can see it's very smooth because interpolation is turned on. And the other thing you notice is that it's not using a standard square card. This is actually using custom shapes. So in the particles, what you could do is you could use some like hand-drawn shapes like this. Just draw it on the plane. And when you export it in that, you can turn to particle sprite and turn on the custom card here and point the merged one that contains the custom card in here. Then you can turn on multiple shapes with shape ID. So the shape ID will let the system know which shape belongs to which particle. Then you can use a shape weight to control the distribution between different ones. So that basically decides how many stars and how many moons am I using in this. Then you can export that here. So it's very good for reducing overdraw if you want to use a particular shape instead of a circle or a square traditionally. The other thing you could do is to have completely looped particles. So if I play this, you'll see that as the color go from the purple to red and recycle the full cycle, it's actually looping to the different cycle, and it's pretty seamless. So in order to do that, you just use one of our labs tools called make loop. So you use a make loop, and the only thing to pay attention to is that, say you want to export 200 frames of animation, you set the last frame of make loop to be 1 frame shorter than the frame of that. Then you can loop back to the starting frame. So you get smooth animation like this. The other thing I'm showing here is also you can see that every particle is actually spinning on itself. Even if I pause it, you'll see it. So that's just driven by time. Now we can spin them however you want. You don't have to spin in the same direction. You can spin them randomly in opposite directions, as well as give each different particle different spin speed and direction. And you can also see the normals on them are consistent. So even though they're spinning, the normal map that's applied to it is correctly computed. I can show you what the normal maps are. So yeah, I just have a very basic normal map plugged in here, and they will be applied to the particle. But another thing I want to show here is we want to have basically more feature parities with a standard particle system, even though we're just doing vertex animation here. So what this is showcase is stretch by scale by velocity. There are 2 ways to do this. One way is to export velocity from Houdini, like I showed before. You could go to the settings tab under the particle sprites, and under the export custom attributes, you can turn on in color, turn on V. By the way, you can export other things here too. So once you have velocity exported, written to the color texture, and Houdini can read it, and I'll show you quickly how this is set up. By the way, don't worry, that's my demo is a bit quick because we're gonna screen cap all these setups and post it on our ArtStation, as well as the Houdini website, our official learning website too, so you can see how to set them up. So you grab the velocity from the color GBA, and you do a loop based on the interframe alpha. So basically loops from this frame data to the next frame data from this 0 to 1 driver. And you convert that into the Unreal velocity. Then you get a screen space, XY speed, as well as a heading. And you just plug them to the corresponding named material function input. Then the function will compute how to rotate the particles as well as stretch them. So you notice that these particles actually have a thin tail. That's because we offer several different standard card shapes. So we mentioned the custom card shapes before. If you turn the custom card shape off and you look at this one, so you have a square card, you have triangle card, and hexagon card. So that one was just a triangle card, and the basic orientation is down pointing or up pointing. You can change their orientation as well. So when you have a down pointing triangle, and you pull them by velocity, you would create this kind of thin tails behind them. So that's particles. Next one would be soft body. Soft body has multiple uses. Standard one was just any kind of soft body deformation. You could use it for cloth or paper or any kind of thing that has a consistent topology. So what this example is showing is also our tangent space normal support. So previously, what you would get, the normal would look like, let me just jump to the old normal mode. So before this version, the normal basically looks like this. So you don't get details on the surface. In order to support correct tangent space normal, we need to compute the tangent vector as well as normal vector. So two vectors to lock down where the normal orientation should be. Then that's sent over through the rotation texture as a quaternion, and that will be computed in the shader and give you back the normal, like so. And that's just a static mesh as a reference. You can see that they have the same normal. And over here is another cool feature you can do with soft body is to do crowds. So because crowds, it'll be very efficient to use instance meshes, and that give you the ability to just, because that is a static mesh, so this whole thing is a mesh. So you could take a baked animation and turn that into a static mesh and encode the animation in it. But what's nice about this one as a new feature to VAT 3.0 is that you could do LD. So the color coding I'm using here is just synced to the standard Unreal color coding here. So it's just LD 0, 1, 2, and 3. So what happens is inside Houdini, you can just prepare all your LD. So in my, yeah. So you take your mesh and you send them basically, in this case, there are 4 LDs. I'm just sending them to 4 different branches. This is 2, 3, 4. So the basic idea is that each subsequent LD will be a subset of points that's on LD 1. So when we generate the LD, we'll use our point reduce tools, and you turn on the use original point position only. So that will guarantee that any LD that's greater than 0 will use LD 1's point. So they can share point data. So ultimately, what we don't want to do in Unreal efficiently is that we just get this texture, right? So this texture is not super big. It's about just 1K. So this texture contains the data necessary to run LD 0. But because we have the point sharing scheme, so every other LD will just write down this, and we don't need to create additional texture data to play it. Then you have this merged version, which contains the 4 different LDs, and you send it to the VAT node and turn it to soft body. And you can go to the advanced tab, and there's LDs drop down. You can turn that on and set it to the number of LDs you have. Then when you do the export, it will just give you a single FBX and a single set of textures. So it's very easy to use. Next thing, rigid body. There's a lot to talk about here in rigid body.
Hey, Mai, real quick.
Yeah.
They're struggling a little bit to see your cursor, and they're wondering if you could pop in and OBS and enable that for us.
Oh, cool.
Do you know how to do that?
I think so, yeah.
So properties on the display in sources, and then there's capture cursor.
Can you guys see the cursor now?
Yeah,
You can?
that's great.
All right, cool.
Thank you so much.
Yeah, sorry about that. So here, there's a bunch of examples in the rigid mode. So one of the biggest things we did with rigid body this time around is to enable interpolation. So interpolation was not a feature in the previous versions. Let's just use this as an example. So this is if I remember right, this animation is about 4 seconds long or something. And if I turn off different interpolation right now, and this is what you would get. This is all the integer frame data that's encoding the texture. So there's not that much data, and there's a big gap between every frame. So once we have the interpolation, you can very smooth position and rotation interpolation. That means that you could reduce the amount of texture you need to export. You can take bigger time gaps between each frame, then use the interpolation feature to get back the smooth animation. One additional feature we have, which I can demonstrate here, is called smoothly interpolated trajectories. What that does is that if I show you this one, and I have this turned off, you will notice that in this circular motion, you will see pieces are going in sort of strange contraction motion. That's because between each frame, what they are doing is they're trying to travel in a straight path from this frame's position to the next frame. And because they have such a high amount of rotation, that means they can't maintain a smooth circular motion. So if you turn on the smooth interpolated trajectories, now they can interpolate in a circular motion. And to support that, you also need to go to Houdini in the rigid body and make sure you turn on the smoothly interpolated trajectories. Then that will give you the necessary data to achieve that effect. The other thing we could do now is we changed how we encode the pivot for each pieces. It used to be in vertex color, now we move it to UV channels. So that way we freed up the vertex color to do other things such as masking. So in this example, let's say I want to destroy this object and I want to have the inside face and outside face to look different. So previously you might want to apply 2 different materials. But the disadvantage of that is that when you have 2 different materials, they will split the mesh in 2 in the rendering stage. So they will get 2 draw calls instead of 1. So it's more expensive that way. What we do now is basically before we do the destruction, when I generate my little piggy here, I will assign the inside and outside a different vertex color. So if I go to this mode, you can see the inside face is a different vertex color. And the only trick to pay attention to is that that requires a different name for the vertex color. You need to change CD to CD_V and move it to vertices. So once you have that, then you don't need to apply it to different materials. So just in Unreal, you could go to the master material and use my vertex color to create a branch. This branch will decide this is the inside texture, I'm going to use the outside texture. So not just textures, but also anything like roughness, you can set different values. So assuming your same mesh is generally using the same shader mode, it's not like one side is using translucent, the other side is using opaque. So assuming everybody's opaque, then you can do something like this pretty easily. You can even apply different normal maps here. So you see the normal that goes into here as a if statement as well. Moving on. This thing is pretty handy. So what you see here is actually 3 different things it's a combination of ism and a hism. So instance meshes. So instance meshes is not just ism, hism. It also applies to like mesh particles or fall H2s. So anything that instance your mesh. So that makes a bit difference in how you export your asset. In order to support instance, you need to go to the Advanced tab and turn on Support Real-Time Instancing. And that will automatically turn on the exporting real-time data JSON file. So in the new VAT, you generally don't need to do the JSON file as you would before, but to support instancing, you need to do that. So once you have the data file exported, you will bring them into Unreal as, if I go to the Instance tab, as the data table. Let's check this. So you have a bunch of parameters here. So in order to set the data table to the material, you just go to the material instance. Oh, flashing. Turn on the support legacy parameters and instancing. By default, it's off. If you turn this on and enable all the things on the left so that it can be set, then be sure to close the material instance. Then just select the data table at the material instance. Then go to the script the actions and choose the first one, so you can apply that. After that, it will be automatically set, and you'll be good to go. This thing is a bit advanced, maybe used less frequently. So it's stretch by velocity. It's similar to the scale by velocity feature in particle mode. So it is enabled because if you look at the rigid body material function, you will see that there's an input called local space piece scale multiplier, and that's a vector 3. That means that you can individually scale each piece dimension in 3 different directions. So what we do is, since we attributed the velocity through the color channel again, we can turn that into unrealized velocity and set it to absolute, so you don't get negative values. Then you apply a stretch by velocity scale, then add it to the default scale of 111. So that will let the velocity stretch the piece for exaggeration. So if I play this, you would get almost like a sort of like a fake motion blur effect. That's useful in animation. Sometimes you need to like exaggerate the motion to make it look appropriate. The other thing we have here is how do you trigger animation on demand. So if I press F here, this thing will play. If I press again, it would play from the start. So that's useful for you to have like event-based triggers. So I can just quickly show the setup in the blueprint. So all you need to do is like replace this F with a custom event you have that signals the start of the animation. So at the start of the animation, you just set the game time at first frame parameter in here. So this is a material instance parameter. If you set this, it basically tells the shader like what's the current game time at the start of the animation, and it will do a subtraction. And the result of the subtraction is that the game will start to play the animation at time 0. So at the beginning, then you can turn on visibility to unhide your mesh, and that starts it. And we also have rigid body LD as well. So the basic functionality of this is kind of similar to the soft body LD for crowds. But because this character is made of rocks, so each piece of its body is rigid. So you don't really have soft deformation. So that makes it even cheaper to animate something like this. So if you look at the texture size of this character, it's only 66 by 133. So that's the number of pieces, and that's the number of frames of the animation. So it's super cheap to just do something like that. Then you also get the same LD switching. So in the Houdini side, what you could do is like the original animation looks like this. And note that this is not a traditional rigid body simulation. So you're not running this through a solver. So you don't get the RBD data, such as the orient, the pivot, and everything. But you can get it using transform pieces. So what you're going to do here is make sure the pieces are packed. But coming out of this thing, everything is packed. You see there's only 66 points. It's not like thousands of points. That indicates that this is packed. Then you freeze the first frame. So this is like the rest frame pose. And you cannot use a extract transform node to compute the necessary RBD data. Then you use that data to transform the pieces using the rest frame. So now if you look at the transform pieces here, you get the same animation, but at the same time, you would get the orient and pivot computed. Then that will be happy. Downstream, we also do the 4 branch thing, so 4 LDs, and they will share point data. Unlike the soft mode where point data is like literally per vertices, this one is just per one of the 66 points. So the sharing is on the packed points. Now, final part, I'm going to open a different project. So for the most part, vertex animations are baked in. But what if we want some interactions? We wanted to be able to have the animation be triggered conditionally based on some gameplay events. So I'm going to show you how to do that right now. So this one is Houdini export animation, about 2 seconds long. This is just the animation, what it looks like. Now I'm going to turn it into something that I can trigger on demand and not play at the same time altogether. So I'm just going to go to the blueprint that contains this mesh and switch to a material that I already prepared, that conditional. By the way, both these projects will be made available so you can play around with it.
I've very much been asking for that, so
yeah.
they'll be excited to get their hands on that. Awesome.
How am I doing on time, by the way? I didn't check.
You're good.
Okay, cool. So this one, now if you shoot it, you can see that only the part that's colliding with your projectile is playing the animation, and it plays independently at the starting from the time the hit event happened. This is the sort of the first stage. You have a independent trigger for pieces. So how it's done is basically we use 2 render targets. So if I look at the draw this, which means the draw this frame. By the way, to see how to use render target, we're going to provide a documentation for this, but you can also learn about how to use render targets in general on Unreal's own documentation page. So the blueprint will send us this overlap location. So when a projectile crosses the collision bound of this mesh, it will, for every tick, it will give you a local position that tells you where it's currently overlapping. Then we'll send this to this material that draws to the render target. It will also reference a little texture here called rest local position. What that texture is basically tiny texture here that only contains the first frame of the position texture. So it's very small. So the full position texture containing all, I think it's 200 frames. Sorry, it's 120 frames. It's like this. But this texture, which is a cropped version of the first frame, will basically tell you the rest position of each piece. When the material look up this rest position and compare against the current overlap position, you can do a little bit of math to figure out if a piece is inside my hit radius. If it is, then I'm going to update my my first render target, which records this frame. And also have a previous render target from the previous frame, and that do a comparison against the current one. So because I don't want to keep updating the render target if I have already updated it, what the render target will store. So let me just kind of show you where the render target is created. So at the begin play of my object that contains my mesh, I will go here, I'll create render target 2D and create one for previous frame and one for this frame. So this frame render target will store the starting game time where the hit event happened. That's why it's only needs to be written once. You don't need to like update it a second time. So if any pixel recorded the first time it hit, then the second time you hit it, you don't override it. That's what the comparison is doing. Then you need the previous frame render target for checking, because as you're updating to a render target, you cannot reference the same render target. That's just a limitation. So that's why we have a previous frame. Now, as you can see here, in my actor beginning overlap, I will turn on a partic boolean here that would let me know that partic I can update my render target. But even at the beginning of the frame, beginning of the event, I will do something here to send the projectile at a location to that parameter in my material dynamic material instance and send the game time. Then we'll tell the render target to update it themselves. Then on the partic part, if that should update render target is true, then we'll keep updating it until the projectile exits the bounds of the actor. Then that's turned off, then this whole thing will stop. So that's the basics of it. Now we're going to take it a step further. I don't like how this piece is just slowly floating out. I want it to be more explosive, to more like almost like in the Inception kind of effect. So I'm going to jump to my second material. Jump to that one. Now you will see that they start to like explode much faster than they slow down. So because of the interpolation ability, we're not restricted by how many frames we have exported and what's the time difference between each frame. We can manipulate the time and you get the smooth animation always. So the interpolation and the retiming basically happens in the master material that controls the vertex animation. So let me do a small comparison here. So this part, you have the G channel of my render target is the time. And in the previous version, you just clamped between the animation time, goes from 0 to about 2 seconds. Then you feed that into the time input. But now what we're going to do is that instead of feeding this directly into the time, we're going to use a retime curve, which you can create here. And the curve looks like this. So this one changes how my time is interpolated. So we'll go fast, then go slow. So that's how it's achieved. Here. So that changes the progress of time. Now, as a final stage, I want to do one step further. I wanted to have these pieces not just float out and stay there. I want them to disappear. And in order to disappear, I want them to like reverse where they are and go back to the hit location. So let me change this to the final one. So now if you see a hit, you'd basically reverse after a certain amount of time passed. And the animation is also a little bit exaggerated so that you can see it better. So there's multiple things in it. Previously, we mentioned sending the time to the render target, but also we're sending the position of the hit to location as well. So if I go to which one? Yeah, this is a little bit. I'll basically just talk about the logic of it. So the render target here provides the red and blue channel provides the location in these 2 dimensions. We know that it's hitting the center of the object in the 0. So like the object space, the white component would kind of set it to 0. Then this node give me the location of the hit. And what I'm going to do is I'm going to interpolate, and this loop does the interpolation. I'm going to interpolate the current location of my piece towards the target location, which is the hit location. So as they're doing the interpolation, I'm also going to subtract them to get a direction. So this normalize and absolute will enable me to do the stretch by velocity, but in this case, it's just by the direction. So they will stretch in the direction they are going. Then on top of that, we have a little bit of, where was that? This node. So this node will scale down everything as they're going back. So they're doing the stretching, but they're also scaling uniformly towards the center of each individual piece. So they will disappear. Cool. Yeah, I think I might run over time, but this is the end of my presentation. And I'll hand over to Simon. Thank you.
Lots of really, really exciting stuff.
Thanks.
I know we had, they're wondering just real quickly, are there, would the Learn site be a place they could read more information on some of the stuff you've covered today, or will that be coming in the future?
So it will be coming to our tutorial on the Learn part. It would be coming to our ArtStation as well. We'll add like more posts. We haven't finished it. There's like 2 posts, but there's 3 more coming. It will also be uploaded to the link as a PDF as a second part. So the first part covers basically the general workflows, and the second part covers the workflow for each of the 4 individual modes.
Awesome. Okay. Well, we'll let Simon dive into Project Titan.
Awesome. Cool. Yeah, I do also want to mention that we are going to build some tutorials for the VAT Vertex Animation, so you know, so you can follow along the tutorial if you want to. Then that's for later coming. So let's talk about Project Titan now. So this is a project we're building with SideFX. We have talked about it before a little bit here and there, and now I want to sort of like bring you another look at what we're building. So let's just jump in first on like what is Project Titan. So this is a Houdini learning and demo project. So we want to use Houdini build something in Unreal Engine. So that's our main goal, to sort of like share how we approach different things, like how did we build this thing, how did we build that thing. So that's something that over time we will share more and more about. So one of our first goals is to build an environment. So we're going to build procedural tools like building tool, other tools to support environment creation. We also want to cover a variety of topics. So it's not only creating environments, but also, for example, using things like SideFX tools, which are for rigging animation and mocap. So that could also be something that could integrate in the project. Other things could integrate in the project as well, like things like Mai showed, like the Vertex Animation tool sets, other simulations, bringing in that in Unreal. So there will be lots of content to come with this project. So for this project, we sort of like created a small team around this. So we have some sort of like direction and idea to go with. So we want to create a futuristic version of Amsterdam where robots play huge parts in the world. So if today everyone has a smartphone, in the future maybe everyone has a robot, and we sort of like have a small story around that. But our goal is to just mainly focus now on creating an environment that looks interesting, that has procedural tools for buildings, for the roads, for the water. So there will be a variety of things that we're going to build for this. So procedural tools will be very important for the project. So they are important that we have them, and they all also need to support artists working on the project as well. So we might have artists that are not super familiar with Houdini. They still need to be able to use the tools. So if we hand them for example, the scaffolding tool here or a building tool, they can just use these tools in Game Engine. So they don't necessarily have to know Houdini. They can just in Game Engine drag and drop tools, and they can play around with these tools to quickly generate buildings, scaffolding tools, roads, cables, wires, a variety of things. So it's mainly there for supporting artists' workflows instead of having to manually place assets. We sort of like generate basic shapes or place assets automatically, so the artist sort of like has less work doing every single thing more manually. A lot of these tools will also use basic shapes as input, like a cube or a line, and from that shape, like a cube, will then be a building or be a scaffold tool. So that's an approach that you will often see, and I will also demo a bit of that in a few moments. Now, if you're not really familiar with Houdini, we also have a Houdini engine, which is a plugin. So this allows us to open basically Houdini files into our game engine. So we can open our, for example, here like the cable tool, we can just bring that in Real and play around with parameters. So I want less cables, I want more cables. We can just tweak that in editor, and we don't have to like know Houdini. We just once the technical artist, for example, builds a tool, another artist could play around with that in your studio. So these are just very tweakable procedural tools in editor. Also, this is also for baking out results. So this is not something that is working like a runtime in the game. This is mainly for making models, variations, or scattering around props and then baking out the results so they get to run in the runtime. So here is like a very little demo of some tools, but I can show you some more in action. So this is, for example, a tree tool. So based on a curve, I can just generate a tree. So I can manipulate the curve, and the tree will then adapt to that curve. I can also, for example, then bring in my parameters that I have. So these are custom interfaces you make. And we can play around with how many branches do I want, the angle of the branches, how many leaves do I want, what color does the leaf have to be. So we can play around with a lot of properties inside of the editor. This is also, for example, a quick row tool based on boxes. So I can just place boxes very quickly, and I can have here a basic road system with that. So these are some like quick demos here, what you could do with the plugin. So very easy to change and tweak things on the fly. So if you ever feel like something is not good enough for your gameplay, you can just tweak those boxes instead of actually having to modify the geometry itself. So there will be a few tools that I will demo here. So I have these three that I will quickly show you here. So we have a building tool, a scaffolding tool, which is made by external artists. So we are working with external artists on this project. So Thomas Marcotte made the scaffolding tool. and also a cable tool we have also here. These three tools I will quickly show then. A little bit more information before I jump in is the building tool. So from basic shapes like boxes, we generate the building. What is special here is that we can actually define patterns. So I can say I want next to my door, I need a window. So I can define that in the tool. So we showed previously building generators before, but now we have this special element to define the layout of certain placements of our modular kit. And this is all driven by data tables. So here we have data tables with my patterns and my models. So again, here I specify what models do I want to use, how they should behave on the building, and so on. So I have a data table in Unreal with my models. So here you can see I have my static mesh. So this is the location, and then this is the pattern naming. So wall A1, and also the size. So this is very useful to get in Houdini, so we can work with specific sizes and use that in our tool. Then I have a second data table. And this is then basically my pattern. So this is gonna, for example, my generic floor will always place my wall number 1. This is of course referencing back to those data tables with all my models. So these two data tables you can just use to build your wall system. So for example, I have my model. I give it a certain naming, like wall A1. I'm going to give my floor generic name, and I just want to have the wall everywhere. And this is then my result. So in my Houdini tool, this is then the output. We can quickly make this a bit more advanced. So in here, I can make a more customized pattern here. And as you can see, I can have, for example, like stairs, doors, or a bar trim here at the top. So I can define that with the pattern. So that is what actually makes this special, is I can really define or art direct now buildings better by just saying what I would like to see on certain levels of my building. Yeah, so the best way to show this is I'm going to jump here into Unreal here. So this is my Unreal demo scene here. So let's jump over here. And here I already have some boxes set up. So these are normal Unreal boxes that you can grab, and I also quickly hide them with the G key so we can actually see my result better. So now it's just a matter of grabbing my tool. So I'm going to go here to my tools and grab the CD generator. And now it's going to like warm up the tool. And once that is done, my tool is basically ready to go. So it's ready now. I'm also going to make sure here at the top we have Houdini engine. So here is where you could find certain settings and make sure your tool is working. So with that, I need to input these cubes. So we're going to go here to my input. I'm going to say pick from the world because I want to pick something that is here in my scene in the world. I'm going to say start my selection, and I'm going to start picking cubes. So these ones, like so. So I have a couple of them, and let's say use as current selection. So now these are now my selection here, and it's currently not working because I have a toggle just to make sure we can also control if this is working or not. So let's enable everything, and it's going to take a sec here, and then we will see buildings here appear. So now we have our modules. So again, here we are using just the generic pattern module. So this is just placing the same module over and over again. What you also notice is that I selected here these cubes as well, but they're not appearing in my tool. And one of the reasons is because we're also working with a tag system. So here, if we go all the way down, we have tags in Unreal. So this is called building B, and this is called building A. So this is pretty cool that I can automatically have different tags and have building variation in styles by default. So if, for example, the level designer adds tags on every different cube, the procedural tool will automatically work with that and add variation. So let's go to my tool here, and I'm going to add a new style. And I want to use B now. So everything that is called B will now have that module. So as you can see, now we have that as well. So let's create some more variation here. Let me grab my data table. So here is my data table with the patterns. And I can now use my patterns here in, for example, my B group. So for example, let's grab floor B. Just going to copy paste the naming here. And we're going to place my generic name with my floor B. And now we have that changed. And you can see that the tool also quickly responded to that. I mean, we're inputting multiple cubes. So this is already like a larger city, and the tool works pretty fast on that. So as you can see, we're having now building variations here. So let me focus a bit more on this building. And for example, I would like to have doors here at the bottom row. So I'm going to grab my door floor, just going to copy paste the naming. And I'm going to say here, hey, can you place the doors at the bottom and then place everything with a generic pattern? So here we have that. I can then, for example, add stairs. So I have something which is a ground floor. And I can say in the pattern, place first the stairs and then the doors. So now we have that here placed. So if you don't like it, you can always just keep changing these patterns and add more, add less. So you can just keep adding. So the idea is that later on in the project, artist can just keep adding to this list here, and they can just fill it in a procedural tool. So we can also do the top one. So trim top, and I can just say here, use the top part for that. And we're going to have the top part here. So we can play around with that and add more. So we can always, if we don't like something, just remove it. And then we have this result. So that's basically how the building tool is working. So again, most of the tools here are still in work in progress, since again, we are still working on this project until the end of the year. So there will be a lot of different tweaks and changes coming along. So yeah, this is pretty cool that you could just fill in different patterns, plug in your own models if you have new models, and the tool would then adapt to these changes. So this was the building tool. So now let's jump over to the scaffolding tool. So I already have it here prepared. This is a scaffolding tool. And again, we are using boxes here as our place to drive this tool. So if I move this box, it will then here change to that position. If I make the box larger, it will also make that scaffold larger. So in the tool itself, we can go and add properties. We have, for example, different styles. So I can change this to another type of style. So now we have this one. This one looks already pretty cool. And again, this is actually based on data tables again. So artists can later on add more styles. So they can add scaffolding style number 3, and then they fill in the models here. So they just fill in the models, and the tool will know what to do with them. So let me switch back to number 1. And we can, for example, add some blanks here on the side. So we're just instancing models on the side to have these blanks. We also have options to, for example, add props here. So let's say I want to automatically add props. So we can here play around with that. So we have some props here and there. Again, this works on data tables. So if I have a data table specifically filled with props for construction work, then this will automatically add props for construction work. So in this case, we have like just some random props like these trash cans and so on. Yeah, so this is basically what this tool is doing. Very useful. Works also really fast. We can again just place boxes, and from these boxes, it will automatically get converted into something that is already close to like a final result that you want to see. So artists can just place around the block out their level, and then automatically you can convert things into as their scaffolding. Then let me just jump to the last tool that I wanted to show you here. That is a cable tool. So here I have these two cubes, and I would like them to be connected to each other. So I have a cable tool that can connect based on surfaces. And I'm also going to use this white bar here as collision. So again, here we just open our tool sets here, drag in our tool. Now it's going to take us a few moments to warm up. And we should then have our cable. So now it looks pretty basic, nothing special. But the cool thing here again is we can go here to our inputs and we can say world input. So select something from the world. And then I want to use my cube. So I'm going to select this one and this one, use as selection. And then it will use this as cables. So now it's just like generating cables based on the geometry. But I actually want to change my setting to connect surfaces. So they will actually search for a connection between them. So this is then the result. So let's say I want more cables. So let's increase the density. So these are more, we can add more. We also have like a maximum radius on how far things can search from each other. We can also have like dynamic scaling. So it will try to find more size between them. We can also here add some, for example, like some ends. So we are placing like some small model there. So, but the cool thing now, it also has simulation compatibility. So in Houdini, we can do simulation things, but we can also like here bring in a certain frame of that simulation as the result. So I want this bar here as collider. So the cables are now going through this bar and it's not that nice looking. So let me go to my tool and go to collisions. So collisions, and we want to say pick from the world. Going to select here and use this. So now I have this as collision. So the collision is not immediately working because I also need to enable here my simulation options. So I'm just going to here hit enable simulation. This might take a moment. And I might also need to hit reset just to be sure I have the correct result here. And as you can see, it works as expected. So now I'm actually simulating these cables falling over that geometry. So you can add more geometries, you can make it a bit more complex. But this is what you get if you enable a simulation here. So you can also move the cubes or add more cubes. Like you can add a lot of different cubes to make things more advanced or noisy. So we can move the cube. It will again do the simulation by default, so it will take a moment, and then you have this result. Now, another cool setting here that we can do is add sub cables, and this will add smaller cables around the cable. So this will again take a moment with the simulation, and this will make everything a bit more interesting, a bit more noisy. Like it will add a lot of different details and cables. So if I would remove that, you'll see that the cables are a bit cleaner here. So you can just play around with these settings to like add more noising and more cables messing around with each other. You can also increase like the topology. So right now you could clearly see that they are like quite low in topology. So you could play around here with resolution to sort of like increase that. You can also like play around with the dimensions. So if they need to be a little bit thinner, so we have something like this. So it's a quite adjustable tool here, and you can do a lot of different things. So that's sort of the cable tool here. So really cool is that you can just do simulation here. This will make it a lot more believable and interesting to look at. So yeah, that works pretty cool. And that is basically it that I wanted to show you. So I showed you parts of the building generator with the patterns, showed you the scaffolding tool, and also the cable tool. So these three tools wanted to show you here. We have more tools, work in progress, and I hope you will definitely hear more about this.
Awesome. Thank you so much, Simon. Lots of really exciting stuff in there.
Awesome.
And we've got all kinds of questions if y'all are ready to answer some things from the community.
Oh,
Um, So, since we were talking about Project Titan, they're wondering if there's a rough time frame of when they can expect to be able to play with it and explore it.
Um, yeah, so we are gonna work until the end of the year. We sort of like have our first more bigger release on like making a scene, and we want to use that as sort of like a first push on the project. So by the
Mhm.
end of the year, you should probably have something. You probably should see something about that.
Awesome. Very cool. Let's see. Um, oh, we're shifting our questions around a little bit. Let's see. They're wondering, one learner was asking, what format is the data stored in? So is it already compressed simple text? Is it compressed when shipping the project? Uh, Anything you can share there?
On what are we specifically talking about?
I think that was during your Project Titan demo, but if one learner you'd like to clarify exactly what data you're referring to, we can circle back on that one. Um, so using the tools that you had, can you actually populate the inside of the buildings for, they're asking around like open world games so that they could go in the buildings as well? Or is that more for just the structures of the buildings themselves?
Yeah, currently we're not planning to do generating insights as well. We're currently focusing more on like a outdoor scene. Um, so yeah, the environment you saw during the stream, that's sort of like what we want to focus on and polish that up, and not necessarily focus as well on generating interiors as well.
Cool. Um, Hiroyanyade was asking, they're saying that 3.0 is amazing and they intend to use it a lot, but they're wondering if you think it'll replace traditional Alembic methods.
I would say it runs a bit faster just based on observation. So eventually, it depends on the development of Alembic, but it depends on the use case. Like we laid out all the different ways you can use it, so maybe you can like look at that and judge for the thing you need to do and see if it works. And also another nice thing in production is just like test it out and see how fast it runs and see how good everything looks. So
Okay. Well, and on that note, Karak was asking if there, oh shoot, keep shifting around. Are there any trade-offs at all, or so from Jim Bachelot, sorry. Are there any trade-offs at all with that-based interpolation in terms of quality performance or memory consumption?
so the memory consumption usually just come from the textures. So the idea of interpolation is that you can export less frames, so there will be less textures. So the trade-off will be more instruction count in the shader, in the vertex shader, when you use interpolation. So if you're not bottlenecked on shader instructions, then you can afford it. Then you can use less textures. If you are, then you can't use interpolation. So it's a trade-off between those two.
Okay, cool. I know there was some folks are asking about the demo project. Again, those are on the ArtStation page, and in the project or in the listing itself, you can find the link. It's not actually in the description, but if you go through some of the slides uh, on the ArtStation page, you can find the download to those projects. So they are there, and you can get your hands on them. So
Yeah, we'll also upload them to the official SideFX sites content library, so you can find them too over there eventually. It's not up there yet, but it will be.
soon, TM. um, Karak's question was actually, are there plans to enable procedural generation for runtime, so not an editor, with the idea that they can generate random worlds that are not pre-generated in the editor? If
Uh,
unsure, no, that's cool too.
no. Currently, it's mainly for the engine is mainly here for making things fast in editor and then baking out results. So it's not something for runtime.
Okay, perfect. Let's see. All kinds of stuff coming in. Someone was asking if Project Titan brings something in terms of USD.
Um, Not fully sure yet. We definitely had some tests before, but yeah, we're not fully sure on how we're gonna like fully implement that. So
Okay. For the buildings, I would imagine so. But are you able to create uh, roofs or the tops of buildings when you're doing that as well?
yeah, currently, I mean, it's still work in progress, and I don't really have a full roof system yet. So I still have to look a bit into uh, building a roof. But I mean, the roofs are quite typical based on what location you're trying to build. So they're always like sometimes a bit specific. So we're gonna look into some roof systems, but yeah, it depends. But it's gonna be in terms of like our Amsterdam style city. So that might vary.
Okay. Let's see. Um, Somebody's wondering, Travis Keller, how do you use these tools with performance in mind? So you're saying a lot of these are about trying to reduce steps and improve that. So how do the generated models like bake down?
Uh, so a lot of these tools, like the house and the scaffolding tool, are basically instancing already made models. So that is just basically placing a model for you. So it's not necessarily creating new geometry. The cable tool is actually generating new geometry. So that's something that you have to keep in mind. Like, can I use this amount of amount of polygons, or you can build settings there to reduce and keep it on the lower side. So I mean, most of the time you actually play around with instancing, like with the buildings. But if you generate some new geometry, you could build settings to optimize it more. I mean, you can even like if you have a middle 5 with nanites, then this might be like less of a worry.
Thank you. Oh, okay. Regarding the data format, so they said, Simon, you had an array up and it said it was text. So they were wondering if you could potentially create programmatically and consume that data later inside of Unreal. For example, making a JSON of the building pieces and randomizing the generation from that.
Uh, Yeah, that could be possible. I mean, for now, we're just using the data tables that are in Unreal, so you could just like right click, create
Hmm.
data table. So those are like things that are available in Unreal and are also like quite artist friendly. So that's why we sort of use them, because artists could quite easily add their own models to it. But yeah, you could try to also like use different files, that like JSON files, and sort of like have every module you have in your project stored in there, and then also like randomize from there. That could also work.
Perfect. Hope that answers your question. Let's see. So for the what else we got? They're wondering, can you use additional output or can you use additional output controls for subsections of an HDA? For example, giving a handle to slide a window across the building surface.
Uh, I mean, you can make as many settings for controlling your building. You could even like do something which is called, I think it's called volumetric override, which is just, for example, saying like, I want specifically here a window, and just place a box there, and then the tool it's like, oh yeah, for this box is I need to place a window. So it's all up to like the tech artist who like builds the tool, how much control gives you in inside of Unreal.
That's the show you're on. Let's see. Oh, they were also asking. So in the case of the scaffold, would anything properly set up then scale and expand without texture stretching any single object if you were to make it larger, for example?
I mean, there is some like auto snapping going on. So it's not, if I place a box, it's not going to be exactly that height. It's going to like sort of like snap a bit either above or under it to sort of like reduce the stretching.
Okay. Let's see. What else we got? So I know some folks had asked, you said this was built in Unreal Engine 5 actually, or are you building in a previous version and it'll just be compatible in the future?
It's built in 5 now.
Awesome. Uh, do your projects, or have you experimented at all with how they interact with like Nanite and some of the other UE5 features?
Yeah, we actually like also use git bash assets and megascans assets. So we like not have to make every asset. And to optimize these assets, I actually made like a small PGG system to automatically also filter out opacity materials, since those nanite and opacity doesn't work together. So I actually made a system that sort of like splits certain parts from the geometry. It's all automatic. So if you have like 60 models, and you need to split the opacity, for example, you need to do a certain process like adding more mesh detail, for example, you can just build a PGG system, which is like an automatic system to do a lot of different things. And you can have that all sort of like automated.
Excellent. They're wondering if you could give some updates on, or some details on the upcoming Houdini kind effects and control rig integration.
Uh, I mean, I don't think so. I mean,
Okay.
we are both not experts at that, so.
Sure. Yeah, we can chase that down. So if there are questions that we don't answer on the stream today, we can always toss them in the forum post, and then maybe we can chase down some folks at SideFX that might be able to share a little more on that. So no biggie.
Yeah. About KineFETs, there are some excellent videos on the SideFX YouTube channel that you can find.
All right.
Yeah.
Is that youtube.com/SideFX?
I don't remember, but if you just Google SideFX, you'll find it. Or Houdini. I think it's actually called Houdini.
Okay.
Yeah.
So check it out on YouTube.
Yeah.
They're wondering if it's possible to use this kind of building generator with PDG to generate a large scale city very fast. I feel like that's what you were doing in many ways.
I'm actually not using PGG for this. So this is actually just, I mean, the tool works pretty fast as you saw in the demo. I mean, if you use PGG, I mean, you often use PGG for like very large tasks. So that might be like, if you're going to build something big, like, yeah, that's probably more recommended. So I just used like 10 buildings and they just quickly generated for me. But PGG is definitely useful if you plan on something bigger.
Okay. They're wondering if you can use these pipelines to place dynamic objects or destructibles or bat items in the scenes, if all that's very doable.
Yeah. I think so.
Yeah,
Okay.
you can, with Houdini Engine, you can instance everything. Like if you have a blueprint or particle, you can just instance those.
Yeah. Especially Houdini Engine V2 has ability to set unreal properties, things like all those things in the details panel with toggles and everything. You can set it directly the string attribute. So you can decide that already through the procedural pipeline inside of Houdini.
Great. And they're wondering if PDG graphs, or it'll only be one way.
Yeah, I think you could import some some data from Unreal. So let's say I have like this big landscape and I want to automatically scatter props or place houses. You could just input the landscape into your system. And then from there, like do your scattering process or manipulate the terrain, for example. So that should be possible.
Okay. Perfect. Well, I think those are our questions for today. Do you have any final comments or things you'd like to share? We really appreciate you taking the time to walk through all of these really awesome features and projects that are coming.
I just want to thank everybody for coming, and thanks to Amanda and the team for graciously hosting us. It's pretty fun to be here.
Yeah, it's always a pleasure to have you all. So, yeah, make sure you're checking out all the stuff at SideFX Labs. I know we're starting to drop some links in the chat. So not only the page on SideFX site, but also their ArtStation where you can download some of these projects and, dive in for yourself and see how they're working. And yeah, the learning paths I think are also a great place to really get familiar with Houdini if you haven't been exploring all that. So thank you all to all of our community members who had joined us today. It's always a pleasure having you. Thank you for all the awesome questions and, keeping us on our toes. And yeah, if you don't follow us on all the social things, find us at Unreal Engine on Twitter, Facebook, YouTube, all that good stuff. And we will see you next week for the Epic Mega Jam kickoff. So hope y'all are going to join us and participate in the game jam for a week and make some really, really awesome projects. So thank you again both to Mai and Simon and Ben and Paul in chat. You all have been wonderful. So hope everyone has a fantastic week.